Today we are starting Unit 7, which is trig proofs. Much like geometry, where you have to show step by step how to get to the correct answer. That's what we'll be doing. Today we are going to start with the basic 8 trig identities. Now, if you notice, we have sine, cosine, tangent, cosecant, secant, and cotangent. All of those are the reciprocal identities. We know that cosecant is a reciprocal of sine. So to write it as a reciprocal, we can write it as 1 over sine of theta. And sine is also the reciprocal for cosecant. So for sine, I could write that as 1 over cosecant of theta. Similarly, we'll do the same thing for cosine of theta and secant of theta. I know that secant of theta is 1 over cosine of theta. And cosine is a reciprocal of secant, so I can write cosine of theta as 1 over secant of theta. And back to Unit 6, when we were talking about the unit circle, we said that tangent of theta is sine over cosine. And if I invert that fraction, cotangent is cosine over sine. Now, hopefully, you already know those 6 identities, and we'll be using those frequently today and throughout this unit. You'll have to have these memorized if you don't have them memorized already. Now, moving on to the Pythagorean identity. Now, the Pythagorean identity, as well as tangent is sine over cosine, those are really what you'll have to know in Calculus 1 and Calculus 2. So make sure you know these identities today. You'll need them beyond this course. Okay, so for the Pythagorean identity, suppose we have a triangle on the unit circle, and if this theta is in standard position, here would be 0, and right here, this would be a radius of the circle, which would be 1. I know for the unit circle, the radius is 1, so that's where the 1 came from. And here, theta, notice the side opposite of theta is labeled sine, because I know that sine is opposite over hypotenuse, so the side opposite of theta is labeled as sine, and the side adjacent to theta is marked as cosine of theta. Now for the Pythagorean identity, first of all, what is Pythagorean theorem? A squared plus b squared equals c squared, where a and b are the legs. Now my 2 legs, I have cosine and sine. Typically for the Pythagorean trig identity, the sine goes first. So it's sine squared of theta. Let me rewrite that because it's kind of weird looking. So sine squared of theta plus the other leg is cosine. So I need to take cosine of theta and square it. So right now I have sine squared of theta plus cosine squared of theta is equal to the hypotenuse squared. And what is the hypotenuse on that right triangle? 1, and 1 squared is 1. Make sure you highlight this, put a star by it, something. You have to memorize the Pythagorean identity. It's sine squared plus cosine squared is equal to 1. And we'll use that on most problems today as well as the entire week and entire unit. Now from that basic identity, we can get all kinds of other identities from it as well. So what if I started with that same equation? Sine squared of theta plus cosine squared of theta is equal to 1. Now what if I divide everything by cosine squared? we know that tangent is sine over cosine. So if I have sine squared over cosine squared, that's equal to tangent squared of theta. Plus, and what's cosine squared divided by cosine squared? 1. And I know that 1 over cosine is equal to secant. So if I have 1 over cosine squared, that's equal to secant squared of theta. So there's another derivative of the Pythagorean identity. Now for that equation, I divided everything by cosine squared. Well, I could do the same process, but instead of dividing everything by cosine squared, let's see if I divide everything by sine squared. So starting with the main Pythagorean identity, sine squared plus cosine squared is equal to 1. Now, what happens if I divide everything by sine squared? What's sine squared divided by sine squared? 1. And what's cosine squared divided by sine squared? Cotangent squared. So 1 plus cotangent squared of theta is equal to, and what's 1 over sine squared? Cosecant. So 1 plus cotangent squared is equal to cosecant squared. And that's not all. We need to see 2 more versions of this. Okay, so let's start over with the main identity. Sine squared plus cosine squared is equal to 1. Now notice I'm using theta because that was our reference angle, but they may use alpha, they may use beta, they may use x, they may use a capital A. It's just whatever the angle is. So sine squared plus cosine squared equals 1. What if I want to get sine squared by itself? Subtract cosine squared. The opposite of add cosine squared would be subtract cosine squared to both sides. So that gives me that sine squared, positive cosine squared, negative cosine squared is a 0 pair. So the only thing I have on the right side is 1 minus cosine squared of theta. So there's another version of the Pythagorean identity. And we'll just do one more. So start with the main identity, sine squared of theta plus cosine squared of theta is equal to 1. Now on that previous example, I got sine squared by itself. What if I want to get the cosine squared by itself? Subtract sine squared of theta to both sides. So sine squared, negative sine squared is a 0 pair. So that gives me cosine squared of theta is equal to 1 minus sine squared of theta. Now that's a lot of identities. Now I am not going to make you memorize all of these identities. The main one that you do have to memorize is this one right here. And you'll use it in calculus too as well. Sine squared plus cosine squared is equal to 1. So if you know the main identity, then you can rearrange it many, many times to get those other identities that are up there on the screen, as well as other identities based on whatever problem you're trying to solve. So you just have to know sine squared plus cosine squared is equal to 1. Now looking at all of these identities, what do all of these identities have in common? They all have a 1. They all have a 1, right? This one has a 1, a 1, a 1, a 1, a 1. What else do they all have in common? Well, yeah, they have a theta, but they all have a term that is squared. So keep that in mind when you're trying to do a proof today. If you see a 1 with a term that is squared, it's probably a derivative of the Pythagorean identity. Sine squared plus cosine squared equals 1. Okay, so let's use these identities. Now, for the first set of problems, the instructions say, simplify each expression to a single term. What does single mean? 1. So I should only have one term in my answer. So number 1, we have two binomials that are being multiplied. How do I multiply two binomials? FOIL or double distribute? Do those terms sound familiar? Okay, so let's go ahead and double distribute. I know x times x is x squared, so sine times sine would be sine squared. So this would be sine squared of theta. So sine of theta times sine of theta is sine squared of theta. Now sine of theta times 1 is just sine of theta, so plus sine of theta. Distribute one more time. What's negative 1 times sine of theta? Yeah, negative sine of theta, so minus sine of theta. Then for the last term, so it's negative 1 times positive 1. Negative 1, so minus 1 at the very end. Now, is my answer a single term? No, so I need to combine like terms. What do you notice right here? Those cancel. Positive sine of theta, negative sine of theta, that's a zero pair. So what's left over is sine squared of theta minus 1. Do I have just a single term? No. How many terms is this? 2. So I have to keep going. Notice I have a 1 with a term that is squared. So this is probably a derivative of the Pythagorean identity. Sine squared plus cosine squared equals 1. So over here I'm going to do some scratch work. I'm going to use S for sine, C for cosine. So sine squared plus cosine squared is equal to 1. Now over here I have sine squared minus 1. So let's see. If I want sine squared minus 1, well first I'll have to subtract 1 to both sides. So I have sine squared minus 1 plus cosine squared is equal to 0. Now the only thing I want to have on the left side is sine squared minus 1. So how do I get rid of the plus cosine squared? Yeah, we need to subtract cosine squared to both sides. So that gives me sine squared minus 1 is equal to negative cosine squared. So there's yet another Pythagorean identity that we didn't do on that previous page. So over here for my answer, instead of sine squared of theta minus 1, instead of sine squared minus 1, what is my answer? Negative cosine squared. So negative cosine squared of theta. Don't forget the theta. So negative cosine squared of theta. So if they use theta in the problem, make sure you use theta in your answer. Now, is my answer a single term? Yes, it's just one term. Next one, number 2. Here again, we are multiplying two binomials. So go ahead and double distribute or FOIL method, same thing. So cosecant of A times cosecant of A would be cosecant squared of A. So this time we're using A instead of theta. And cosecant of A times 1 is cosecant of A. Distribute the negative 1. What's negative 1 times cosecant of A? negative cosecant of A. And what's negative 1 times positive 1? Negative 1. Do I have a single term? No, keep going. What do I do next? Combine like terms, and what happens with positive cosecant of A and negative cosecant of A? Those cancel. So this is just cosecant squared of A minus 1. Do I have a single term here? No, but I probably have a Pythagorean identity because notice I have a 1 with a term that is squared. So this is probably a Pythagorean identity. So start with the main one. Sine squared plus cosine squared equals 1. So this is just my scratch work over here. Now if I have cosecant, actually it's cosecant squared, but think about cosecant. What's another way to write cosecant? 1 over sine. So if I want a 1 over sine, that means over here with my 1, I'm going to have to divide by sine. But I don't want cosecant, I want cosecant squared. So I need to divide both sides by sine squared. Instead of writing out sine squared, I'm just going to use s squared. So divide everything by s squared. So what's sine squared divided by sine squared? 1. And cosine squared divided by sine squared is cotangent squared. And 1 over sine squared is cosecant squared. But over here I have cosecant squared minus 1. So what do I have to do here? Subtract 1 to both sides. So that gives me cotangent squared is equal to cosecant squared minus 1. So instead of cosecant squared minus 1, what is my answer? Cotangent squared of A. Don't forget the A. So it's cotangent squared of A. So over here, if you're doing your scratch work, you don't have to use the A and write it out. This is just my scratch work, so I'm just using S and C and not using the A at all. Okay, next one. Number 3. Here, we are just distributing. But before you distribute, do you notice anything? Yeah, we have a term that is squared, and what else? A 1. So what do you think could happen in the middle inside those parentheses? What would that probably be? That's probably a Pythagorean identity. So let's see what's the identity. So sine squared plus cosine squared is equal to 1. Now I need to have a 1 minus cosine squared. So how would I get 1 minus cosine squared? What would I have to do? Subtract cosine squared to both sides. So sine squared equals 1 minus cosine squared. So over here in the parentheses, let me bring down the cosecant squared of x. And instead of 1 minus cosine squared, what could I replace that with? Sine squared. Now, is that a single term? No. So after you've taken care of any Pythagorean identities, the next hint I would give to you is change everything to sines and cosines. So get rid of a cosecant because it's not a sine or cosine. So what's another way to rewrite cosecant squared? 1 over sine squared. So this would be 1 over sine squared of x. And this is already in terms of sine, so keep the sine squared of x. And if I put this over 1, what would happen? Yeah, sine squared in the denominator will cancel with sine squared in the numerator, so what's the answer here? 1. So the answer is just 1. Is that a single term? Yes. Now for number 4. First thing, see if you have a Pythagorean identity. Do you see a 1? No. So we don't have a Pythagorean identity here. So if you don't have a Pythagorean identity, what I would probably offer up is to change everything to sines and cosines. So let's keep sine of x. Instead of cosecant, how could I rewrite that using sine or cosine? 1 over sine of x minus, and I have sine of x. Yeah, go ahead and distribute sine of x. So what's sine of x times 1 over sine of x? 1. And what's sine of x times negative sine of x? Negative sine squared of x. Is that a single term? No, but notice we have a 1 and a term that is squared, so it's probably a Pythagorean identity. So over here I'll do my scratch work. So sine squared plus cosine squared equals 1. Over here I have 1 minus sine squared. So how would I get 1 minus sine squared? Subtract sine squared to both sides. Yeah. So we get cosine squared is equal to 1 minus sine squared. So my answer is just cosine squared of x. Is my answer in simplest terms? Not simplest, is it a single term? Yes. Next one, number 5. We have a sum that needs to be squared. We have a difference that needs to be squared. Oftentimes, most people, when they try to square a binomial, they would just say that this would be sine squared plus cosine squared. That's wrong. So let's just refresh on a little bit of Algebra 1. If I have a binomial that is squared, you're going to have 3 terms for your answer. So to get the first term, take the first term and square it. So if I take a and square it, that gives me a squared. To get the middle term, multiply these and double it. So what's a times b? ab, and when I double it, that gives me 2ab. This is always the term people forget. Then to get your final term, take the last term and square it. So b, when you square it, it gives you b squared. Now, it's pretty similar if you have subtraction in the middle. First term, when you square it, it's a squared. But when you multiply these, you get negative ab. When you double it, you get negative 2ab. And negative b, when you square it, you get positive b squared. So there's just a little Algebra 1 review. And those trinomials are called perfect square trinomials. Okay, now let's use those shortcuts to go ahead and square those binomials. So take your first term and square it. So sine of x, when you square it, you get sine squared of x. To get the middle term, multiply them and double it. So sine of x times cosine of x is sine of x cosine x. When you double it, it gives you 2 sine of x cosine of x. Take the last term and square it. So cosine of x, when you square it, you get cosine squared of x. So that's the perfect square trinomial for sine of x plus cosine of x, that sum squared. Now moving on to the next binomial. Take the first term and square it. So sine of x, when you square it, you get sine squared of x. Multiply those, you get negative sine of x cosine of x. When you double it, you get negative 2 sine of x cosine of x. And when you square the last term, negative cosine of x, when you square it, you get positive cosine squared of x. Whew. What do I do next? Combine like terms. What are the like terms? Let's hold off on that first. Let's hold off. 2 sine of x cosine of x, negative 2 sine of x cosine of x. So this is just sine squared of x plus cosine squared of x plus sine squared of x plus cosine squared of x. Now somebody was already saying, okay, sine squared plus sine squared would be 2 sine squared. But I said, hey, let's go ahead and do these long ones first. Why do you think I wanted to hold off on that? Do you see anything? I hope you do. What do you see? Sine squared plus cosine squared, that's an identity. Sine squared plus cosine squared is equal to 1. And I have it again. Sine squared plus cosine squared is equal to 1. So this problem turned out very simple. It's just 1 plus 1, which is, oh my goodness, it's 2. 2. 1 plus 1 is 2. 1 plus 1 is 2. There's a question? Uh-huh. 1 plus 1. Uh-huh. How did we get 1 again? Because it's our identity. Sine squared plus cosine squared is equal to 1. Okay. Okay, next one, number 6. Now, number 6, this problem is just kind of misplaced, and really we don't have a way to solve this, but there's one thing we do need to point out with number 6 is that you can factor trig. So you can factor trig. Notice this is in the same form of those 2 equations or formulas that we just used, where the first term is squared, the last term is squared, the middle term is 2 times the sine of both of those square rooted. So this is a perfect square trinomial. So to factor a perfect square trinomial, if I went back, if I started with sine of x plus cosine of x, here, this is actually what we're looking for, or what we're looking at. Let me get a highlighter. So if we were given these 3 terms, to get the binomial, you take the square root of the first term. So what's the square root of sine squared? Sine. You take the square root of the last term, which is cosine, and then you keep the sine in the middle. So it keeps the positive. So let's do that to factor problem number 6. So if I square root sine squared, what do I get? Sine. So this would be sine of theta. If I square root the last term, I get a 1 and drop down the sign from the middle. So this would be a plus. So we're not solving that one. I just want you to know that if you have a trinomial, you could factor a trinomial with trig values. Now for this last group of problems, it says to simplify the left side to equal the right side. Now you may see instructions that say verify. And when we're verifying, all we're doing is a trig proof. So what we're doing on problems 7 through 10 is what's called a trig proof. We are proving that's equal. So we're proving the left side is equal to the right side. So notice you do have to do what the instructions say. It says to simplify the left side to equal the right side. So that means you need to start with what's on the left side of the equal sign. That is the only side we are going to do operations to. We're not looking at the right side and doing anything to the right side. We're just working with the left side only. Now, if you are one of those who likes to utilize photo math, if you just take a picture of that, it's going to do steps on both sides of the equal sign, and you're not going to get credit. So you need to make sure you start with one side and show that it equals the right side. So you're not working with both sides simultaneously. So starting with the left side, we have tangent of x divided by sine of x. And we have to do operations to that to prove that it's equal to the secant of x. Now, there's two main pieces of advice I can give you. The first one is look to see if you have a Pythagorean identity. So do you have a 1 in that problem? No. So no Pythagorean identities here. If that doesn't work, change everything to sines and cosine. So instead of tangent, how can I rewrite tangent using sine and cosine? Sine of x over cosine of x. Now the denominator is fine. It's already in terms of sine. But I'm going to make this sine of x over 1 just to simplify things a little bit. And how do you divide by a fraction? Multiply by the reciprocal. So the first fraction, the numerator, is sine of x over cosine of x. And when I multiply by the reciprocal, I need to multiply by 1 over sine of x. What do you notice? Yeah, sine of x in the numerator will cancel with sine of x in the denominator, and that leaves me with 1 over cosine of x, and 1 over cosine of x is equal to secant of x, and that's the right side. So notice we started with what was on the left side, and we showed using trig identities that it's equal to the right side. Now, did I do operations to the right side? No. I started with the left side, and I only did operations to the left side only. So I started with the left to prove that it's equal to what was on the right side of the equal sign. Next one, number 8. Now, we're starting with the left side, so I'm going to rewrite it. So we have cosine squared of x minus sine squared of x. So we're starting with that, and we need to show that it's equal to 1 minus 2 sine squared. Now, the two main tricks we can use when we're doing trig proofs. First of all, look to see if you have a Pythagorean identity. Is that a Pythagorean identity? No, we don't have a 1. So the next thing is change everything to sines and cosines. But everything's already in terms of sines and cosines. So if those two tricks don't work, then really just look at the right side. So notice for the right side I have 1 minus 2 sine squared. Well, on the right side, does it have a cosine in it? No, so we have to get rid of the cosine squared somehow. Now, one other thing we do need to notice. On the left side, we have a negative 1 sine squared, but on the right side, what do we have? Negative 2 sine squared. So that means somehow I need to get rid of cosine squared, and it has to have, well, it has to have a 1 and a negative sine squared. So if it has a 1 in it, it would have to be an identity, the Pythagorean identity. Sine squared plus cosine squared equals 1. I'll do my work down here. So here's my scratch work down here. Sine squared plus cosine squared equals 1. Now we have to get rid of the cosine squared. So if I wanted the cosine squared by itself, what would I have to do? Subtract sine squared. So that gives me cosine squared is equal to 1 minus sine squared. So instead of cosine squared, I'm going to replace it with 1 minus sine squared. Then I have minus sine squared of x and what does that equal? 1 minus 2 sine squared of x. So again, we started with what was on the left side of the equal sign, and we proved that it's equal to what's on the right side of the equal sign. So start with the left, prove that it equals the right. Yes? What did we do? Well, we noticed in our answer we had a 1. So if you have a 1, it's going to be a derivative of the Pythagorean identity. Sine squared plus cosine squared equals 1. So if we started with a cosine squared, but the answer does not have a cosine in it, we had to get rid of the cosine. So we solved for cosine squared by subtracting sine squared to both sides. And when we did that, we got 1 minus sine squared. So instead of cosine squared, we replaced it or substituted in 1 minus sine squared, which is right here. And then minus sine squared, that gave us 1 minus 2 sine squared x. Okay, 2 more problems. Next one, problem number 9. Now, again, we're starting with the left side. So we have cosine of x minus 1 over sine of x. So start with the left to prove it equals the right. Now, one of the first tricks is see if you have a Pythagorean identity. Well, we have a 1, but do we have a term that's squared? No, so that didn't help me. So if you do not have a Pythagorean identity, the next trick is change things to sines and cosines. But notice everything is already in terms of sine and cosine. So those 2 tricks didn't help me. So if you look at the answer, our answer has to have a cotangent. And what is cotangent? It's cosine over sine. And what is cosecant? 1 over sine. So all we have to do in order to get that is each term in the numerator has to be divided by what's in the denominator. So we're going to split this up. So cosine of x, the first term, needs to be divided by sine of x. Now negative 1 is the second term. It also needs to be divided by sine of x. So we're splitting up that fraction. So cosine is divided by sine, and negative 1 is also divided by sine. So we're splitting up the fraction. And we know that cosine over sine is equal to cotangent. And negative 1 over sine of x would be negative cosecant of x. So we started with the left side and proved that it equals the right side. Okay, I want you to do that last problem. I want you to do problem 10. So start with the left side. You have sine of x over cosine squared of x minus 1. You need to prove that it's equal to negative cosecant x. one of the tricks is to change everything to sines and cosines. Well, that trick won't help us here because everything's already in terms of sine and cosine. So what's the other trick? See if it's a Pythagorean identity. Notice we have a 1 and we have a term that is squared. So that's going to be a Pythagorean identity. So start with sine squared plus cosine squared is equal to 1. Now notice I have cosine squared minus 1. So the first thing I need to do is subtract 1 to both sides. And to get cosine squared minus 1 by itself, subtract sine squared to both sides. And that gives me cosine squared minus 1 is equal to what? Negative sine squared. So this is just sine of x over, instead of cosine squared of x minus 1, what do I need to put? Negative sine squared of x. And what if this were just x over x squared? What would that equal? 1 over x. The x in the numerator will cancel with only one factor in the denominator. So same principle here. The sine of x in the numerator will cancel with only one sine of x factor in the denominator. So if everything cancels in the numerator, we're left with a 1 over negative sine of x. And 1 over negative sine of x is equal to negative cosecant of x. So we show that the left side is equal to the right side. Now, was that the only way to work that problem? No. With equations, there's more than one way to get to the correct answer. So let me show you one more method because I think some of you might have used it. So instead of cosine squared, if I have sine squared plus cosine squared equals 1, instead of cosine squared, I know that cosine squared is equal to 1 minus sine squared. So in my second equation, instead of cosine squared, what could I replace that with? 1 minus sine squared. So this would be sine of x. And then I have 1 minus sine squared of x minus 1. Those ones cancel. So this is just sine of x over negative sine squared of x. Sine of x in the numerator will cancel with one factor in the denominator. So that gives me 1 over negative sine of x, which is equal to negative cosecant of x. So there's definitely more than one way to get to the correct answer. So I don't care which one you chose. There's not one method that's better than the other. They both got you to the same answer. So more than one way to solve these equations.